Hey, this is Nate here. In this video, I'm going to go over how to apply camera shake in GameMaker. Camera shake is one of those things that, it supplies feedback to the player, and it's really important to have it in most any game, like not just action games. Puzzle games have it, driving games, all sorts of games use camera shake to convey, feedback to the player to, what's going on. And in this video, I'm going to go over 4 different types, and these types of camera shakes will all pretty much allow you to design anything you want for feedback to the player. It's very robust. It's not just adding random numbers to your camera view. I have like a Sine Wave one and Perlin Noise, and there's also a way using animation curves and even sequences, so you can see I do that. It's just a random sequence I made. This one down here, the bounce, that's actually a sine wave one, but it's like a more specific way so that the sine wave matches up to how many times you want the camera to bounce. And it's really robust. Like I could turn up the amplitude and the frequency and you get a different kind of shake. And another thing I've seen people, they never use the angle as much, but the angle really helps. See, it kind of looks really nice when you add the angle to the shake. It depends on what you're trying to convey. And I could turn up the duration here. It just shakes back and forth. And I can blend in and out. Let's see, I'll blend in really slow and then blend out really fast. So it starts slow and it gets more intense and then it should stop, suddenly. I recently made a video also about Perlin Noise and how it can be used for camera shake as well. And I use it in here for one type of the shake, and it's useful. Like you can see, it's more like an explosion or an earthquake, and things are bouncing around, kind of random, but not fully random. That's kind of the useful thing about Perlin Noise. And sine waves too, very useful. So when I combine them, right here I have it set up now. It's just like he's in a boat or something. Maybe you could imagine. It's rocking back and forth. And then you can combine them at the same time. So like if you're in the boat and maybe it hits something like that, the boat hits another thing, you can convey that with another shake and it'll combine them too. Or maybe there's the big wave and it bounced over the wave like that. It's really cool. You can just combine them like that and have this one that's persistent. By setting the duration to 0, it'll just repeat infinitely. So really useful, very designer friendly on whatever you want to create. So here I have a project open with some code isolated, and I'm going to start kind of from the outside and work inward, kind of at a higher level first. And the biggest part is how you actually apply camera shake, and that is with these 2 functions here. In whatever camera system you have, you're usually going to see at least this one, set view position. Some people don't use the angle one, but in this case we want our camera shake to have angle, so we're using that too. And if you look at these, all I'm doing is this X and Y. Those are the X and Y of the camera itself, its position, and we're adding a camera shake X and Y to it. And this is a struct, this cam shake variable. And this X and Y is basically the addition of multiple camera shakes after they've been updated. And then those get added to this X and Y. When the camera's not shaking, they're 0. And the same thing with the angle. It's just the accumulation of all the other camera shakes going on, added up to make a final value. I also have up here where the camera is clamped to the room. I have a padding value, and that goes along with the camera shake struct component. And that padding value is just it's a kind of optional, where if you want your camera shake to not show the edges of the room when it's shaking, you want to add that padding value to how you clamp your camera within the room. And that's for, like, if you say you have like a tile map that goes around the edges of your room and you don't want the player to see where it cuts off when the camera shakes, you would want to put this padding there to give it extra room, so when it does bounce, you'll just see more of the tile map, but they won't see where the room cuts off. So that's optional. So this is how you actually apply camera shake to a camera. And these 2 functions are the main ones. Then if I go over here and I have this whole library set up for all my camera shake stuff, the core part of it is this camera shake component. This isn't the values themselves of where it's shaking, but this is what runs through all of the different structs that contribute to that. So here's the X, Y, and angle, like I showed over there, where I added them to the camera itself, and then the padding value. And then what this whole struct really does is it keeps track of this DS list, And then in this update function, it iterates through that list and calls the update function on each of those camera shake structs. And when it does so, it passes in self, which is this whole struct here. This is considered self. It's this scope. So it's passing in this scope to this update function. And within that update function, it's then going to add to this X, Y, and angle according to whatever it does, whether it's Perlin Noise or Sine or whatever. There's also a speed value that's optional here, and that comes, I pass that in from the camera itself. So suppose you have slow motion or hit stop or something in your game where the camera needs to slow down for a second. You would pass in that value here. Normally it's 1, because if you multiply anything by 1, it stays the same. But you know, if you're going, say, half speed, it would be 0.5, something like that. So it iterates through the list. It calls the update. If the update returns true, that means that camera shake is done, and then you delete it from the list. You go through the list backwards, because if you're deleting from some kind of data structure while iterating through it, you want to go backwards. That way the size doesn't change and you don't go past the size. Because if you're, say if you have an array that goes from 0 to 9 and you're deleting as you go, you're going to go past the end of that data structure because you deleted as you went. But if you start at the end, it doesn't matter because it'll shrink as it goes. So there's also this clear function. This is called after you apply the camera shake. So after here, after you add it to the camera position and the angle, you want to clear it. It's not removing the camera shake structs that do the shake itself. It's just setting it back to 0 because each time these updates are called, it adds to these. So if you have like Perlin Noise and Sine Wave at the same time, those are getting added. It's going to be X plus this, Y plus that, and those will be added up. And then after, you want to clear them back to 0 so they can get added again, depending on what's going on. We don't know what's going on. This update function, when we call it, will do that, and those I'll be going over next. And then to actually add a camera shake struct to this list, there's just a little wrapper function here that way you can call this camera shake component, and you just add, and then you give it the camera shake struct that you created previously, or you could even create it, you know, within the argument itself when you pass it. And then stop just clears the list, stops all of them. That works great for every case except for if you do use sequences and you have the sequence looping. A looping sequence isn't going to destroy itself. It's just going to keep looping forever. So you would need to destroy that yourself if you were stopping everything. It's kind of an edge case, so it's not something we would really need to include in here. And then this destroy is just kind of just for prosperity here. Like typically your camera stays around for the entirety of your game, so you never really need to destroy this list because when the game closes, you know, you're fine. But just in case you did need to destroy this camera shake component, you would want to call this destroy function to get rid of this DS list. So here at the top of this script file with all my camera shake stuff, I got the 4 main ones I mentioned before. There's Perlin Noise, Sine Wave, animation curves, and sequences. The Perlin Noise and Sine Wave ones, those are very similar, so there's a lot of overlap in their like variables and functionalities, so they inherit from this cam shake base struct. The animation curve and sequence ones, those are kind of standalone. They do their own thing in their own way, so they don't need to inherit from anything. But just to reduce redundant code, it's nice to put the other 2 to inherit from here because it's a lot very, very similar. So the arguments, I'll go over them here. So the amplitude, that's like the size in which the shake's going to be on the x-axis, the y-axis, and the angle. Just think of that as the size or the distance from where your camera normally would be. Frequency is, think of it as speed, but you know, frequency we usually use when we're talking about sine wave or sampling from something, how fast we're doing that at. So those are your size and your speed of your shake, and you got your X, Y, and angle. Then the timing values, the duration is in milliseconds. When it first starts out, it grabs the current time. That way down here in the update function, you can see it's also checking current time. So here where you created it, it grabs the time now, then later it can check how far it is towards the duration, or sorry, towards the time finish by checking the current time as well. And it calculates the blend in and blend out. That way it knows, you know, how to do the interpolation. So if you want it to not suddenly be jerky or however you want it to blend in and out of the shake. This update function here is like the core part really is, and this is what is called by the camera shake component where earlier I said it passed in self. Right here is where it receives that. So camera shake component is where it's getting that self variable. And then it checks if it's done yet by checking the duration and the time finish. It needs to check if it's bigger than 0, otherwise, because 0 is basically infinite shaking. So if you want this shake to keep going until you manually stop it, you set your duration to 0. Otherwise, you give it a duration, and right here it'll return true because it's done. And then here it calculates the blend. It just uses some linear interpolation to calculate that. And then it calls this calculate shake function, which again, it passes in that shake component, so it has access to the X, Y, and angle variables, and it can update those accordingly. And the time is what we grabbed here. And speed, that was that one in case your camera system does. This is where it eventually ends up getting past 2. And the blend, which was just calculated there. So here it's not done, so it would return false because it's still, the camera's still shaking and things are going on. This reset function, kind of an optional thing. If you wanted to reuse a camera shake struct because you wanted to just repeat the same, these here, amplitude, frequency, angle, if you wanted to use that same shake over and over, you need to call the reset first, just because the current time needs to be updated, and that's going to affect the start, finish, and the time in and out for the blending. So you need to call that, and then you would just add it back to that camera shake component so that it uses that same struct again. Because when up here where it finished and returned true, it kicked that struct out of its DS list. It said, okay, it's done. It doesn't want to see that anymore. So here you could stick it back in and say, well, use it again. I reset it. So the two that inherit from that, they're a bit shorter because everything's handled up there in that cam shake base. As you can see, here's the Perlin Noise one, and the Sine one's even smaller because it doesn't need any additional variables. And as you can see, the math looks fairly similar, and it really is, other than the function is drastically different. Perlin Noise is not the same as Sine, but it's the same concept. They're just they're sampling or creating a way to alter the X and Y and the angle of this camera shake component. And the Perlin Noise, I created a tutorial not too long ago for sampling Perlin Noise in GameMaker in a way that's super, super fast because it is kind of math heavy if you were to do it manually every time you called it. This is safe to do thousands and thousands of times. It's not a big deal. And I have a link in the video description on my Perlin Noise tutorial as well. And there's a whole library here in this project too. This is the whole Perlin Noise setup right here. It does everything for you with a buffer. So it, like I said, it inherits from cam shake base. It grabs these random values within the Perlin Noise buffer, and that's just so that if you were to start at like 0 every time and sample the Perlin Noise and not move around, it would shake, but it would be like the same shake every single time because you're starting from the same spot. So you want to start at some random position within the Perlin Noise buffer, but then move from there, and it'll give you a different shake every time. So it'll look nice. And then the values up here that were originally passed, the amplitude and the frequency, that's where they're finally used right here. So we have frequency times time. And so frequency, if you imagine it was 1, then time's just going to be the value, and it's going to move through the buffer based on time. Smaller value means it'll be smaller, it'll move slower. Bigger value means you're going to skip over values and it'll shake quicker. And we multiply whatever this is returned. This returns a value between -1 and 1. So if we multiply it by the amplitude or the size of our shake, we're going to take that and we're going to scale it either in the positive or negative by a certain amount. And then the blend is going to be, normally it's going to be 1 when there's no blending occurring. Otherwise, it's going to be a value between 0 and 1. So when the blend first starts, it'll be 0. When it's finished, it'll be like 0.99999, and then it'll hit 1 and it'll stop blending. And that's the same for all 3 lines here. They're just different variables for the X, Y, and the angle. Everything's pretty much the same as that for Sine, except right here, the time, we calculate the time difference because with Sine, we want to ensure that the sine wave starts at 0. After this code part, I'm going to get in OneNote and draw out just a little bit on sine waves and how they work, just so it's a little clearer and it helps you understand how to use this. But it's good to start at 0. So if we take the current time and we subtract the start time, that's going to start the sine wave at 0. Because on the first time you go through, the time and the start time are going to be the same. So it's going to be something minus itself, which will be 0, which means in here where it's going to start at 0, which means our sine wave is going to look nice, and it's not going to jump suddenly to somewhere weird in the sine wave. So, and then we multiply it by frequency, just like we did with right up here. We multiplied time by frequency, and again, times the amplitude and times the blend, and that's going to give us our cam shake on our X, Y, and angle. The other two types of camera shake I have set up here are animation curves and sequences. So let's look at an animation curve first. Here's what an animation curve is when you create it within GameMaker. And what I do is assign a channel for shake X, shake Y, and shake angle. And then over time, it's just going to read these and apply those to the camera shake X, Y, and angle. And suppose one limitation here too is if you wanted, say, if you turned it to linear like this, you wanted your X shake to for some reason be, you know, straight lines like this. You can't do that within a single animation curve. So what you would do is you would create more than one animation curve and split up your X and Y and your angle according to which one you want to do, you know, which model here. And in fact, if you didn't have, say, a lot of times you might not want the angle. You don't need to have the angle. You can pass no one to the, you can pass the keyword no one, and it'll just use nothing, and it'll assign it 0. So this is it. It just reads this or however many of these you have. And right here's the struct. So as you can see, curve X, curve Y, and curve angle, that's the actual animation curve that I passed in. And in this case, I'm using the same one. You could use 3 different ones, or you could type no one and it would be fine. Then you give it a duration in milliseconds and whether you want it to loop or not with a Boolean. It sets a start and end time. It remembers those values. And then it grabs the channel from the actual animation curve right here for the X, Y, and angle. And if it doesn't exist, it just assigns it to no one because, again, they're optional. Here's the update function that's called by the camera shake component. And if here it's checking if it's looping or if it, you know, the end time has happened, then it returns true because it's done. Then it calculates the time based on your duration and speed, and it grabs that, or it gives it 0 according to whether you have a channel that exists or not. So it's going to return the value wherever it is in the position along time, and it's going to add that to the X, Y, and angle. So pretty simple. That one, if I turn up the duration, that one looks like this. I made the angle go really crazy just so it's really obvious what's happening. I wanted just a big example to show you have full control over the 3 channels, which is really nice for this one, because technically you could probably do something crazy with sine waves and get something similar to like this, but this gives you full control for something really granular that you want to define in your camera shake, depending on the situation. Then the other one here is a sequences. And let's look at the sequence first. So here's the sequence. It's nothing special. I just made this weird triangle, and then the camera, the view tilts a bit. And the way it works is you make your sequence, and this sequence will be read by the struct, and it actually creates it at runtime like a normal sequence, and then it creates it at 0, 0. That way, wherever this position goes, it can read directly and apply that to the camera as some sort of shake value. You want to set your color multiply to, you know, just basically turn off the alpha so it's invisible. Otherwise, here, if I delete that, you would see this little sprite I have here that represents the view. You would see that, and you probably don't want that while your camera's using it. So it just creates this, it reads from it, and then it gets the values. And here's that sequence in motion. It's not interesting, but I just made it so I could know it's working. So there, it goes in a tiny little triangle and it tilts the view a little bit. But, you know, this gives you full control over, you know, a lot more elaborate things you may want to do that you wouldn't be able to do with just sine waves and Perlin noise. So the code itself, again, this has almost pretty much no arguments, just pass in the sequence. It's going to create this static layer that it references in this struct and whatever struct uses this. And it's going to create the actual sequence at 0, 0, like I mentioned. It's going to give the struct. And then in the update function, again, it has the camera shake component and the speed. It's going to check if it's done or if it exists. If not, it's going to exit. And then it does adjust the speed. So if your camera did go in slow motion, it would tell the sequence to go slower. And then it just gets into the active tracks, grabs the X, Y, and the rotation, and assigns those to the camera shake components, X, Y, and angle. Just adds them up, and it's just like the other one. Returns false if it's still going. And like I said, it looks like this. Not an interesting one, but while it's doing that, you know, if say you have something going on here, you could add something to it at the same time. It's kind of big, but yeah, there you go. There's a sequence doing your camera shake for you. So one extra function I have here, it's not an actual like constructor, struct, or anything like that, because what it does is it calls cam shake sine. It makes a sine wave camera shake, but it's called cam shake bounce, and it does the same thing, except instead of having to calculate how many times you want the sine wave to bounce, this does it for you, and that's basically changing the frequency of the sine wave is going to affect how many times it bounces according to the duration you set. And so if you give it a direction that you want it to bounce in, you know, 0 to 360, and then an amplitude is how far it's going to go, a duration, and then the bounces is the number of bounces it's going to do for how many times it bounces. So if we look here, I have it set to, let's see if I can get it at 1. It's about 1 bounce. It's going to go, see, there's just 1. And this would be useful if, say, you have like a player that get hit from the right side. You want it to look like the camera jiggled to the left some, because that's where it would go when they got hit from the right. So it would look like that. And while it does that, you know, you could add in like Perlin Noise at the same time. That's kind of too big, but you know, you could combine them to make the hit look a lot more realistic or interesting than just a random camera shake. So you could use the bounce, and you could make it so that it kind of bounces, and maybe do like a blend out. So there it's like that's probably too big. Yeah, so like imagine he got hit from coming from the right. It's gonna go left more, so that's why we have the blend out, but the blend in is gonna be low. Blend out, I'll do a little less. There you go. So that, and on top of that, you could add like, you know, some Perlin noise, so just a little bit, so it jiggles as well, but you'll have that overall shift, so it looks okay, cool, he got hit from the side. And that way you can really fine-tune and make the feedback of your game way more interesting than it would be with just random camera shake. So the last part I wanted to talk about was how the sine wave ones work, and this is just a general good thing to know if you don't use sine waves very often, because sine allows us to oscillate things really easily. Cosine you could as well, but sine starts at 0 when you pass in 0, so it's just more convenient to use sine. The range for sine and cosine for that matter is actually 1 to -1. So if we like extended this here, the range that it returns is 1 to -1 by default. So if you were to just call sine of, we'll just do theta. If whatever theta is, it doesn't actually matter. It's going to return something between 1 and -1. And then what's nice about that is we can multiply it by something to do whatever we want. In our case, we multiply it by the amplitude. I'll just put amp. And then that's going to change it to, say the amplitude was 10, this will now create a value between -10 and 10. And what we can also do with it, depending on what theta is, and in the case of camera shake, we're using time, theta, we can multiply it by something to get this wave here. We can make it look, let's use this blue, we could make it look smaller, you know, scrunched together, or it could even be stretched out even further over time. And by multiplying theta by a value that's either 1, which will do nothing, or less than 1, it'll make it go slower, it'll be stretched out. Or if we multiply, say we multiply it by 2, then this curve here that goes up and down, it's going to happen within the span of right here, this area. So it would look more like that. It would shrink it up. So that's why it's called frequency. It's how often it occurs. And another part of a sine wave too that's good to learn is there's the phase shift, and there's a vertical phase shift and a horizontal. The vertical is really easy. After this part here, you just add like some y value, and it moves this whole thing up or down. That's it. For the phase shift, there's different ways to calculate it and how it works. The way we're doing it is we're just remember I said I want it to start at 0. I'm just doing time minus start time. That way, whatever time has elapsed since it started, it'll be 0. So I'm just ensuring that my phase shift puts it at 0. So technically it's not doing a real phase shift. It's just ensuring we don't have our camera shake starting in random spots with a sine wave. We want it to start at 0. And just to add to that, so it's illustrated properly, we have sine of theta, or our time, times we have our frequency, and then we multiply it by our amplitude, and it's multiplied by blend. So that's, again, the exact same math I had in the camera shake struct. And then in that bounce one, all I'm doing is I'm calculating, let's just say this line here, the x-axis, this is time. I'm just calculating how within the time, say I wanted my time to end right here, I'm calculating what does the frequency need to be in order for the number of curves or bounces to occur within this time evenly. So with, like, if it was one bounce, I would calculate it like this, and this curve right here is pi, or 180 degrees. So all you have to do is make sure that those 180 degrees gets passed over within whatever this time is. This could be whatever milliseconds you want. And the math in the other, let me go back to it. Right here, it's just, you remember 180 degrees or pi. We're using degrees here just to make it easy, times the number of bounces divided by however long you want it to last. And that's going to give you a frequency that will make your sine wave happen like I described here, however many times you want it to go up and down. So if you had 10 bounces, you would need to, the frequency would be like this. I'm not going to count exactly 10, but you get the point. It would need to go up and down really fast, so you would have a higher frequency within that given time. And that's just how it works. And there's a million things you can do with sine waves. They're used all over in programming, computer graphics, etc. They're really useful because they oscillate between 1 and -1, and that's a really nice range to do whatever you want. And in this case, sine wave, see, bounces, tons of bounces. They're really great. Well, that's it for this video on camera shake. Again, it's a really useful system to have in pretty much any game. It provides, really valuable feedback to the player, and it kind of portrays what action's going on in different ways. Or like I said, if he's in a boat and things going up and down, you could do that and make it feel a lot more interesting than just like flat images where the camera doesn't move much. So this project is just me adding on to my display manager and camera tutorial. It's the same project there. I just added onto it and created an asset out of it. So if you're interested in that, there'll be a link in the description to the actual asset itself, which you can get. But anyway, thanks for watching. I hope you found this useful.